Okay guys, so 2.3 is talking about investigating slope graphs or f-prime graphs. This concept is not really hard. It's just you have to really learn what parts of the graphs mean. So we're going to look at the original functions and then we'll look at the graphs of the derivatives. So when you hear f prime, that means derivative, like this right here is f prime. So it says, when you plot the motion of an object as velocity versus time, these are referred to as slope functions or f prime graphs. So that's the derivative. You use these in calculus and physics. They represent the rate of change of the original function. So by analyzing these graphs, you can find out where changes are occurring slowly or quickly by observing the rates of change or slopes of the tangent lines at a specific moment in time. So for example 1, this one is just kind of showing you where the points come from on the derivative graph, the f prime graph. So it says, consider the function shown at the right and notice the curve at the first point x equals 1/2. So here's x equals 1/2 and here's that point right there. It says the slope of the curve here is about 1. So if we draw a tangent line there, our slope is going to be about 1. And then at x equals 4, that's here, that tangent line, the slope is decreased to about 1/3. So if we went up 1, it'd go over 3. So our slope would be about 1/3. So it says, it gives us a hint, and it says, when x is 1/2, so when x is right here, f prime is 1, because whatever the slope is at that x value, that's going to be our y value for the derivative. So at 1/2 on the f prime graph, it's going to be, let me just show you here. Let's look at this. Okay, so at 0.5, right here, our slope is 1, and at this one it just happens to be like the same point. It's not always going to be like that, but at 1/2 our slope here is 1, so that's where that point goes. Okay, and at 4 our slope we said was about 1/3, so here is 4 1/3 as an ordered pair. Okay, and for the rest of these points, to get them, you just kind of have to guess, and they don't have to be perfect. But I put a note down here that said, the closer that f gets to the y-axis, so the closer that it gets here, the steeper the slope is, meaning the larger the number. So if we graph this, the closer it gets to the y-axis over here, the steeper it's going to get up this way. Okay? And then the further away it gets from this y-axis on f, the less steep the slope gets, so the smaller the value gets over here. That's probably a little confusing, and that's okay. I just want you really just need to kind of understand the concept and not really be able to do this specific part right now. We'll get to that later. All right, example 2, it says comparing the graph of f to the graph of f prime. So I'm gonna have to scroll up and down because we'll have to answer some questions and then look at the graphs. But I want to talk about one thing really fast. You may have heard me mention points of inflection or concavity before. So when a graph opens down like this, this is concave down. And when it opens up, that's concave up. So a point of inflection is right here in the middle where it stops being concave down or up and changes direction. So, and that's right in the dead center of where it changes, okay? So this is your POI or point of inflection, okay? And it says the point of inflection is where the graph changes concavity. And I just put POI as point of inflection. So this is where it changes concavity from being concave down to concave up. Okay, that point is going to end up being important later. If we look down here, it says the f prime graph gives us insight into the behavior of the original function. For example, at x equals 1, the slope on the original function appears to be almost -2. So at x equals 1, here's 1, we can almost say that the slope is -2 because if we go down to over 1, it's pretty much -2, right about. Okay, so it says, therefore, on the f prime graph, the value at x equals 1 is almost -2. So that's the point on that graph. So whatever the slope is at a certain point at like 1, whatever the slope is at 1 on f, that slope value becomes the y value on f prime. Okay, so there are several relationships between the two graphs that are particularly important to note, and we're just going to look at these and go into more depth in the next page. So the first thing to look at is concave down. It's concave down, and I changed that number because I think it's more of a 1.5 than 1.8, what they had. But it's concave down from negative infinity because it starts out that way to that 1.5. And then it changes to concave up from 1.5 to positive infinity. And then the other thing we're going to look at is over here, f prime of -0.9. So like right here, that's going to be where it crosses the x-axis, and it also crosses at 4.2. And if we look at those values, -0.9 is right here. That's going to give us this max value. And 4.2, like where this one crossed the x-axis over here at 4.2, that's going to give us this min value. So that's important to note for the next page. All right, so this is continuing on with those graphs. It says, when the graph of the function, which is f, is rising, we're going to say that the function increases, and when the graph is falling, we'll say that it decreases. It's customary to read a graph from left to right, just like we read a book. You know this already. All right, so starting at the left on the graph of f of x, so the very first one, it wants us to state the intervals of x where the graph rises, where it's increasing. And what do we notice about the slope of the curve on these intervals? So the first thing that we notice is that it's increasing from negative infinity to -0.9. Okay, so flip back to that previous page and look at that. So on the graph of f, so that first graph, from negative infinity to -0.9 is where it's increasing. Okay, then it decreases, which we'll put in the next problem. And then from that min value at 4.2, it increases again, to infinity. And the slope of both of those curves at those points where they're increasing is positive. So that's pretty easy to see. And then it says, starting at the left, state the intervals of x where the graph falls. What do you notice about the slope of the curve on these intervals? So we've already said that between -0.9 and 4.2 is where it decreases, and that's the slope of the curve is negative. It's going down to the right. All right, then it asks, at what values of x on the graph of y equals f of x does the function appear to have a max or min value? What does the slope of the curve look like at these points? And what are the characteristics of f prime? And so, let's see. We've talked about the max and min. So it has a relative max, we said, at -0.9. And a relative min at 4.2. And those are on, that's if you're looking at the function of just the normal function f of x. But if we compare that to the graph of f prime, I put a little note here that on f prime, those points are the zeros or x-intercepts. We kind of touched on that on the last page too. And the last thing, the slope of the curve at -0.9 and 4.2, that slope is 0. So that also tells us that at -0.9 and at 4.2 on f prime, the y value is going to be 0. So meaning those are the x or y, or the x-intercepts or zeros of the function. Okay, now it says to look carefully at this one. Why does the graph of f prime of x reach a max or a min value near x equals 1.5? So can you explain what is occurring at 1.5 on the graph of f of x to create this minimum on the slope graph? So yes, we can, because what did we say was 1.5 on our original graph? We said that was the point of inflection. So that's where it changes from concave up to concave down. Wherever that happens on your original graph, that's going to be either a max or a min value on your f prime graph. Okay, and don't worry yet, we're gonna write all of these down on the back of these notes. So you'll have like a list of what is what instead of having just a bunch of random things. So let's move on to example 3. I might have to stop in the middle of this and make the part 2. I don't really know. I have like 5 minutes left on this video. Okay, so it says the procedure to sketch an f of x or an f prime slope graph from f of x. Step 1 is to describe how the slope changes from left to right along the curve, and notice the intervals where the slope is positive, negative, and 0. And then we write down the changes as they occur from left to right on a number line. Notice where the x-intercepts occur, and pay attention to where the function is above the x-axis and where it's below the x-axis. So we are only looking at this first graph because this is g of x, and we're going to use this to make g prime of x here in a second. So when we have number lines, we're going to use 2 number lines for each graph that we do. Sorry if you hear Campbell in the background. Real sorry. The first number line we're going to look at where our function increases and decreases. Okay? And so here, it decreases first from left to right. It decreases until x is 2. So first it decreases, and that's at negative 2. I'm sorry. Negative 2 is what I meant. Then it changes from negative 2 and it increases to the value of about 3.3, 3.5. I think they put 3.3. Okay, so it increases between negative 2 and 3.3, and then it decreases again forever. Okay, so that's the first thing we're looking at. Now this is going to tell us something about f prime, or g prime in this case. So before we do anything else, let's see what it's doing to the derivative. So where f is decreasing, f prime is going to be below the x-axis, and they denote that with the negatives because it's negative or below. Where f is increasing, that's positive, meaning it's above, and then it goes back to decreasing, which is negative and below. So, and you can actually see where I have it covered up over here. From negative infinity to negative 2, it's below the x-axis right here, then above and below again. So that's how you figure that out. All right, the next part we want to look at are the x-intercepts. So remember, wherever our max and our min values are on the function, that's going to be the x-intercepts for our f prime or g prime. So at negative 2, that's a min, and that's going to be our x-intercept because our slope is 0 there. See where the slope is 0. And that's the same thing for 3.3. That's also going to be an x-intercept because our slope is 0. Okay, so now we know this, and I've covered this up too. This is our point of inflection here that we talked about in the last part. Excuse me, the last part. It goes from concave up to concave down. So, and that's about 0.8, I would say. Close enough. It's not exactly at 1 yet. All right, so let's go ahead and look at this next number line here. This one we're going to look at concavity. So we've looked at increasing and decreasing and what it does to the derivative. Now we're going to look at concavity and what it does. So this function starts out as concave up, okay, until our point of inflection, which is 0.8. And then it turns to concave down. All right, so what that does to our g prime, when it's concave up, that means our g prime is increasing. When it's concave down, it's decreasing, so the slope of those. We don't know that this is our max yet, but we can infer that it's going to be whenever we start looking at, it starts out as increasing until that point and decreasing. So obviously it's going up and then reaching a max value and then coming down. So that's how we know that. All right, before we actually sketch this, I'm going to pause this video and start part 2 because I'm about to run out of time.